Hello everyone, my name is Kawai. In my video presentation, I would like to talk about cryptography. Here is the outline of my presentation. First, I will talk about the problem, which is insecure channel. Next, I will introduce Caesar cipher, Affine cipher, and how to tackle a cipher. Then I will end my presentation with modern cipher. Imagine there is a problem where a sender wants to communicate with a receiver. However, the channel that they are communicating is not secure. How do they overcome this problem? First, what is an insecure channel? For example, Ben and Randy want to communicate with each other. Ben sends a message hello to Randy, but the channel is insecure. There is a third person named Eve wants to look at their message. To overcome this, Ben will have to encrypt his message to another word. Then send it through the insecure channel. Now Randy will have to decrypt the word back to the original message. This system is known as cipher system or crypto system. The word that has been encrypted to is called ciphertext, and the original message is called plaintext. Now, if only able to see the ciphertext, and she knows about the crypto system, except certain information. In general, cryptography is the study of technique to secure communication through an insecure channel. The simplest cipher techniques are Caesar cipher and Affine cipher. Caesar cipher is a type of substitution cipher where each letter is represented by a number. To encrypt the message, each letter in the plaintext is shifted by a certain number of places down the alphabet. The number of characters to shift the cipher alphabet is known as key. Caesar cipher alphabet can be considered as modular arithmetic with n equals 26. In modular 26, the maximum number representation is 25 and the lowest number representation is 0. The alphabet A to Z is represented by number 0 to number 25. Before communication, both the sender and receiver agree on the key K. The encryption function is the ciphertext equals to plaintext plus the key in modular 26. For decryption, the function is plaintext equals ciphertext minus the key in modular 26. For example, keys equals 3. This picture shows the plaintext and the ciphertext with key equals to 3. As shown, the number represented in the plaintext is shifted by 3. The alphabet A is encrypted to letter D, and the alphabet Z is encrypted to letter C. This is because 25 plus 3 equals 28, but in modular 26, 28 is represented to number 2. The key space for Caesar cipher for English alphabet is 26, which means that there are only 26 possible keys to use in this cipher. A key space for a cipher is the set of possible keys of a cipher. A Affine cipher is also a type of substitution cipher, but it is more complex than the Caesar cipher. A Affine cipher consists of two keys called A and B, but the selection of key has a restriction. A Affine cipher is also considered as simple cipher, as the message encrypted using a simple mathematical function. A Affine cipher can be considered as modular arithmetic with m equal to 26. Both the sender and the receiver have to agree on the key A and B. with a restriction where GCD, greatest common divisor, of A and M must be equal to 1. The encryption function is ciphertext equals key A times plaintext plus B in modulo 26, while the decryption function is plaintext equals inverse of A times C ciphertext minus key B in modulo 26. The greatest common divisor of A and M or GCD A M is the greatest integer that divides both A and M. For example, GCD of 3 and 26. 3 is divisible by 1 and 3, while 26 is divisible by 1, 26, 2, and 13. Therefore, the greatest common divisor of 3 and 26 is 1. But why the greatest common divisor of key A and modulo M must be equal to 1? Let's consider the following case. If you want to encrypt the following plaintext A, B, C, D, E, F until Z using a Affine cipher with key 13 and 4, then the ciphertext will be look like this. The ciphertext consists only of letter E and letter R. This is because the greatest common divisor of 13 and 26 is 13. This table shows the plaintext and ciphertext of a Affine cipher with key 3 and 4. Now let's encrypt the alphabet O, which is represented by number 14. The ciphertext of alphabet O is 3 times 14 plus 4 equals to 46. But in modulo 26, 46 is equal to 20. Hence, the alphabet O is encrypted to letter U. Now look back at the previous situation. If able to see the ciphertext, knows the cipher system, but she does not know the plaintext and the key. What can If do to decrypt the ciphertext? There are methods to decrypt the ciphertext: brute force attack and frequency analysis. From previous slides, we know that there are 26 keys for Caesar cipher for the English alphabet, and for Affine cipher there are 312 keys for the English alphabet. Brute force attack is simply systematically checking all possible keys until the correct one is found. In the worst case, this would involve checking all the entire key space. Frequency analysis breaks the ciphers based on the observation. This is because there is a characteristic distribution of letters for English, and substitution ciphers like Caesar ciphers and Affine ciphers do not change the distribution. Frequency analysis uses frequency statistics of ciphertext to make smart guesses for the key. In the English language, the most frequent used alphabets are E, T, A, and O. After analyzing the ciphertext, we can match the alphabets to guess the correct key and break the ciphers. In conclusion, Caesar cipher and Affine cipher are classical ciphers. They are no longer used in modern applications as they are susceptible to attacks based on frequency analysis. There are more complex ciphers such as Crystal Cipher and RSA protocol are used in modern applications. Here ends my presentation. Thank you very much for your time and have a nice day. Bye.